Okay, I messed up again. Here where I applied the initial condition to the homogeneous solution, that's right, it's the homogeneous solution, it's all you have, but we have to apply the initial conditions to the entire solution, which includes the particular solution. It's a no-brainer, but I was looking at where I wanted to go and messed it up. So we don't do this here. We do get the particular solution, okay, and from the double angle formula, or the sum of two angles formula, this becomes what it does. I was going to write it out here. There isn't room, and we're going to see it in a minute, okay? So, we have a little aside here, just verifying or deriving the formula for cosine of alpha plus beta, which you should be able to do in your head. In case you forget it, and you probably will if you don't use it frequently. Okay, so here's our particular solution from before, which we developed. We have to add that to our solution to the homogeneous equation and then apply the initial conditions, which leads us in a straightforward manner to this. We're going to have two cosine terms here, and they've got to add up to 0. Of course, the sign is 0 when t equals 0. So if y of 0 equals 0, the b has to be 0. The a has to equal negative 1 over omega squared minus omega 1 squared. So our solution then will become, well, both this term and this term will have a coefficient of 1 over omega naught minus omega 1 squared, except this will be negative. So we're going to factor that out, and we're going to have this cosine, which we already had, but then we're going to have minus this cosine. Okay? Now, omega 1 is alpha minus beta. And if that's the case, then omega 2 has to be alpha plus beta. Okay? Now I'm questioning the sign of the beta there. Yeah, that's right. That's right. Okay, go back to the definition of the alpha and the beta. You see if you do alpha minus beta, you do get a positive cosine of omega t. That's actually, I don't like that. Let's look at it. Okay. So if alpha is this, beta is this, we have this. And that's all right. That's all right. Okay. You can work out the details of that in terms of the common sense, but here we have it. Well, the same thing, omega naught is therefore alpha plus beta. Okay. If we add the alpha and the beta, it's very straightforward to see that we get omega naught. So that this becomes cosine of alpha minus beta t minus the cosine of alpha plus beta t. Now, if you just plug into this formula, and I'm not going to wave my hands over, just just write it out, and you see very quickly that what this becomes, the cosine terms go away, the sine terms reinforce each other because of the negative here, and you end up with 2 sine of alpha t sine of beta t. Remember at the end I said I wanted sines here because that's really what I've drawn, and that's what it has to be if we're starting from rest. It does work out. The trigonometric details are very similar, but we don't have this solution. What we have is this solution. And we can see then, one other little thing here, the omega naught squared minus omega 1 squared, let's just write that out. That's omega naught plus omega 1 times omega naught minus omega 1, just the difference of 2 squares, and that's alpha times beta. Okay? So I can, it's actually 4 alpha times beta, because alpha is omega naught plus omega 1 over 2, so this is 2 alphas. And similarly here we got the 2. Again, that's just simple algebra, you can work that out. So we end up with 1 over 4 alpha beta times 2 sine alpha t sine beta t. So our final function is well, it's 1 over 4 alpha beta times this, but this has a 2 in it, so it's 1 over 2 alpha beta times the sine of alpha t times the sine of beta t. We don't have to do this questionable limit thing here, although that works. But it's a little more involved than just the hand waving I did. So as omega 1 approaches omega naught, beta approaches 0. So this term gets very big. So this factor out in front gets very big, your amplitudes get very big. You have a sine of alpha t, which is what this is, it's what I wanted it to be. Well, you have a sine of beta t, okay? That's the one with the long frequency, the long period, the low frequency, and a sine of alpha t. And now they're both sines and everything works out nicely. And this was fallacious simply because I applied the initial conditions at the wrong time. Okay? Mathematics is okay, except the solution, when you include the homogeneous part that does have to be included with the initial conditions, is not going to be compatible with this. So this isn't valid, but most of the reasoning is, and the trig manipulations are. This is the way it really plays out, giving us this. And it has all the properties that we've talked about.